We are living in very interesting time. The number of research papers is growing rapidly. Only this year, in March, 2,000 papers about AI and machine learning has been sent to one of the most popular websites with research papers. It means that it's over 60 a day. So I don't want to go for holiday. I don't want to even take a day off because it's very hard to catch up with recent trends. So I have a good news for you. Today I will not show you another research paper. I will focus on very simple methods, but apply them into the real problem and see how to deploy the machine learning into the real business. Who am I? My name is Marcin Druzkowski, and I'm working as a data scientist at Ocador. We are selling a lot of Waitrose brands products, but also all stock around. So as a data scientist, I was working on many different projects. I have more than 6 years of experience in data modeling, data science, machine learning, mostly in the technologies like Apache Spark, TensorFlow, and of course Python. If you want to contact with me, feel free to use this email or connect me through LinkedIn. As a data scientist, you can be exposed to many different projects like customer segmentations, where you want to split your customer base for marketing reason. Sometimes you need to forecast the demand, and for the huge retailers, that's what you will need to do. And there are also some possibilities to try analyzing the text, and today I would like to share the experience from our project about the text. How many of you heard about Ocador at all? Plenty of you, cool. So for all of you who are not familiar with Ocador, Ocador is the largest online grocery retailer. We have over 12,000 employees in UK, and we are just supermarkets. So the problem which we are solving is that you don't need to go to the supermarket for your groceries, for your fruits, whatever. We will deliver this to your doorstep. And that retail space generates a lot of problems, a lot of possibility to optimize the overall business processes and the technology behind. So as I said, we are fully online, so we don't have the physical shops. We keep our whole stock in highly automated warehouses. We call them customer fulfillment centers. And we are building the technology in-house Ocador to manage robots to help us pick and later deliver the food to your doorstep. Because we don't have the physical shops, we have only the 2 real points of contact with our customers. First, when our drivers deliver the food, and second, when you as a customer will decide that you need to call us or write us an email through our contact center. And of course, we need to keep customer very happy on both of these contacts. The most important thing for us is to have the exceptional customer service. And I would like to share the experience from the project, NLP project within the contact center space. So how the typical contact center works? When the new email or new call comes to your contact center, it's land at the end of the queue, because most of the traditional contact center works in a FIFO manner. So first in, first out, or in other words, first in, first served. The customers can write us emails about almost anything, and when I say anything, I really means anything. So some of them will ask for refund because the product was damaged. Some of them will raise the issue about the credit card, the payments issue, and some of them also will ask us for adding a new product to our stock. As you can see, not all of these requests are equally urgent, and if your card is blocked, you would like to be handled much more quicker than when you raise a request for adding a new product. And if the contact center is working in traditional way, it's not possible. So when contact center manager came to us to ask for help, what he can really do with that state, we, as a data scientist, we switched off our computers and went there for 1 day working as a proper contact center advisor. So we set up the headphones and we talked to real customers to see how the application works, to understand the process. And that 1 day learns me more about the whole machine learning space than whole my study, because I understand that to deploy machine learning successfully, you need to understand the environment when that model will work. When I went there, I learned that the reality looks more like this. So plenty of new emails coming every minute, and people who are working in contact center cannot optimize their processes because they don't know what the content of email until they read them. And sometimes, in case of the spam messages, when they will read them, it's already wasted time. So we need to somehow organize this. The business goal for the whole project was to have, at the end of the project, have chart like this. On the x-axis, we have the urgency of the email. On the y-axis, there is a time spent in a queue. So the urgent emails, like payment issue, should be handled in a matter of minutes, and very low urgent issues can be handled in hours or even never, sometimes in case of the spam. Okay, so what we can really do? We can build the machine learning model which will return the list of tags for the particular email. And later, based on the tags, we can determine what is the final priority of the email and put the emails into the right place in the queue. So let's see how it works on the exemplary email. There is an email from real customers, and she's telling us that she has children, so she would like to buy online, and that's why she's using us. The machine learning models should return that email is about feedback, and based on the sentiment analysis, we can say that customer is happy here. Later on, based on these two tags, we can simply say that it's not very urgent issue, and there is no immediate action needed. From the machine learning perspective, for all of you who are data scientists, it's pretty simple multi-label classification problem of the text. So to deploy machine learning successfully, you need to know what you really want to optimize. So you need to define how will you assess the accuracy of your model. And we went for a pretty standard metric F1 score, which gives us a very nice trade-off between precision and recall. There is no proper data science talk without complaining about cleaning of the data. So I will not be an exception here. And I will talk about how dirty could be the cleaning of the data. In our case, because it's emails, so in emails you will find a lot of PII data, a lot of personal identifiable information like names, like postcodes, like telephones, and laws obligates us to delete all this kind of data before we really process them. So that's why we need to somehow clean them. And it's a pretty painful process. You need to use a lot of regular expressions. You need to use also some name entity recognizers to find the names, to find the addresses, etc., etc. And as common in the machine learning space, you also need to get the proper labels for your training examples. So we took the old data from old categories and somehow inference them to the labels to learn and teach our models in a supervised way. Okay, we have the clean, properly prepared the data set, and it's very, very tempting to just take the random research papers, and there is 2,000 every month, of these papers and try to implement the state-of-the-art technique on the top of this data. And from my experience, 100% of data scientists and people related with machine learning overcomplicates their model. They are so ambitious that they want to work on something ambitious, and they are just using techniques which are not good enough for the case. From the business perspective, when you are sitting with the business, when you are talking with them, it's crazy idea to start with something so complex like neural networks. You should always start with something very simple, and you shouldn't be even afraid to start your product, to push it without any machine learning at all, or even some very simple heuristic. Because machine learning should optimize something rather than be a technology just for the sake of the technology. So what we did, we built by few lines of code, we built the very simple logistic regression model on the top of back of words. So it's few lines of code, very, very simple, and that simple algorithm got the 0.4 F1 macro score. As you see, it's significantly better than the random solution, but that solution, it's all about for checking our hypothesis, for validates them. So thanks to this solution, we have been able to find few bugs in our data pipeline, in our data cleaning process, and it also shows that this solution could work. I mean, we got the feedback from contact center engineers that, guys, that's a great tool, but accuracy is so low. And that's feedback, it's exactly what data scientists would like to hear, because the fun can start now. So what we did later, when we got the feedback that everything is working, everything is fine, but the accuracy is pretty bad, we went for the most common choice to improve that accuracy, and we built the convolutional neural networks on the top of the word embedding, and we used the TensorFlow. So for all of you who are familiar with TensorFlow, I shared the three very easy tips, but these tips can help you build a better model in the future. So one sentence about the TF-UP-Flux module. TF-UP-Flux module is very thin wrapper on the top of ArcParks and gives you ability to expose your parameters of the models as a command line parameters. So later on, you can get very reproducible solution, and I will show that at the end of the presentation. Later on, safe model. A lot of people who came to that space, the TensorFlow, they are still not familiar that the TensorFlow revolutionized the way how we saving the models. And thanks to this, we can very easily took the other person model, restore that, and retrain or add another layer on the top of them. So it's pretty nice, and everyone should know that. And the last tip for the TensorFlow geeks, TFDB. TensorFlow has a proper debugger, so if you have any problem with your code, just use TFDB and TF-Assert. When you want to run the word-to-vec, because we wanted to build the neural networks on the top of the embedding layer, as an embedding layer, we went for word-to-vec. As always, you don't need to write anything from scratch. The model is already built, so that one command line will build your whole word-to-vec model on your data set. And if you want to, for all of you who are not familiar with word-to-vec at all, it's the changing of the changing words into the vectors in such a way that the words with similar meaning or similar context will be very close to each other as a vectors. And that very simple algorithm, simple tricks can build you very sophisticated things later. If you want to evaluate that simple algorithm, you can see here that when you take the vector of the London, take the minus of England, you will get something like the capital of the country. Later, when you add that to France, you should get the Paris. So it's pretty simple algorithm, nothing to say more about it. But the magic happens when you will start that algorithm on your data. That one command line generates us these nice pictures. And I have a question to you all. I've hidden the words behind the question marks, and I show you the 5 words which are the closest in case of the distance in vector word-to-vec space. So the question for you: what are these words behind the question mark? Beer, excellent. And on the other side? Nope. 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 But a good shot. No? The word is behind the question mark is a competition. So the old management books says that you should listen customer, and this is the final example that you should listen customer, because they will not only tell you what they are drinking, but they will also tell you where they will go if you screwed up. Before deploying the machine learning to production, you need to always, I mean, especially in neural networks, you need to find the hyperparameters. Especially neural networks are very sensitive to hyperparameters, to any changes in starting parameters. And you have a lot of different strategy to find the hyperparameters. One of them is a grid search, when you just exhaustively going through all combination of your parameters. But there is also the others, like random search, when you sample the parameter space, or much more sophisticated, the Bayesian approaches, or a tree of Pearson estimators. Like always, and I'm saying this on every conference, don't write any code at all. Everything is already there. So in this case, there is a very nice Python libraries to do that. Okay, how the final solution looks like. When the new emails come to the contact center guys send us the content of that email, and our machine learning model return the list of tags. The guys from the contact center also send a lot of metadata about the emails, about, okay, what customer really ordered, when the driver went there, so all metadata about that issue going to BigQuery. So thanks to that, we can later analyze how many tickets of this kind of category was there, and as a training data, as a storage for this data, we are using Google Cloud storage. Okay, so because we have a human in the process, so you need to be very, very, very careful when you are deploying the machine learning when the human are in the process. And in our case, our advisors needs to be sure that we don't want to get rid of them. I mean, in the future, in the long term, it might happen that the solutions like this can replace what currently advisors are doing, these people who handling the call centers. So to be sure that the system can work and that these people will help us build the systems even better, we need to build the trust between human and machine learnings. And in this case, we shouldn't think that human versus machine learning. We should think how the whole process can work when we add the human to the tools. So when we augment and improve the humans by the machine learning. And in this, I can share a very funny example, because we are in London. So British people are very Monty Python driven, and they are using a lot of sarcasm. I come from Poland, and we are not using so much sarcasm there. But in Britain, there is a lot of sarcasm. And one of the emails from the consumer was that because we damaged one of his item, and it was the birthday cake, so he sent us, "Thank you, Ocador, I will have a nice birthday." And our model said, "Okay, it's a happy customer, everything is fine." So it's very, very, very important to always remember that there is a human there. And because of the human is there, we need to also somehow ensure that the model can work with that human. So what we did is the 10% of the advisor still categorize the emails manually to ensure that in the long term we still gather the proper data. So we don't want to get rid of them at all. And they also help us to see this kind of examples like this sarcasm, because if we would just deploy this and forget, we would even don't know that the customer wasn't happy. When you are deploying the machine learning into production, you also need to answer other questions like how will you make your predictions? So should be a batch prediction, should be the online prediction. So there is a lot of technical details which needs to be handled, and tell your engineers to reuse as much code as they can between the training pipeline and serving pipeline, because that can generate a lot of problems later. From the business perspective, business needs to adjust their processes, the SLAs, the KPIs to the machine learning. And what happened when we deployed our system is some of the SLAs cannot be met because there are always something more urgent than the low important emails, and you can starve the low important emails at all, starve to death. So you need to also take care of what are the business SLAs, what are the KPIs, and also what are the incentive systems. So you need to educate. Okay, we did it. We deploy machine learning to proper production. It's time to celebrate. And from the business perspective, that celebration is too early. Because technical people always think, finally, we did it. Finish the project, deploy to production. But from the business perspective, they just say, hey guys, it's just only the investment. Right now, we need to see how it works in real life, how it really handle the customer issues. So it's not time to celebrate. It's time to really monitor that stuff, and it's time to giving the value and money back, because everything before it was just investment from our side. And the funny thing is that most of the projects fails not during the development phase, not at all. They are failing just after the deployment. And I will show you the 3 reasons why projects fail after deployments. Machine learning project fails after deployment. The first one is the lack of monitoring. The guys, data scientists, when they finally found the good model, they are so happy that just from exploratory lab, they just want to move that as soon as possible to the production. They don't think about how they will monitor that stuff. And the monitoring is very, very important. In our case, as I said before, we encourage 10% of our agents to still categorize emails to have that monitoring and to see, for example, that one of the tags is going down, and we cannot predict this very well. The second problem of the deployments of machine learning is that data scientists forget that they are writing the software, and the whole company is forgetting that they are, at the end of the day, they are wrote some software. So the machine learning models needs to be treated as a just normal software. So it needs to be code versioned, it needs to be tested, well tested, some CI environments as well. So everything should be done properly from the software engineering point of view. And the third reason why the project fails is the reproducibility. What we can gain with the reproducibility? You are much, much, much more confident about the results, and also your data scientists are happy to switch between projects, because it's very easy to jump into the project, reproduce the models, later add few layers, change models. It's very, very easy. So in this case, John Ioannidis, who is the professor of medicine at Stanford, claims that most of the research papers findings are wrong. I mean, they false. He and his colleagues analyzed thousands of papers around the world from the medicine world, trying to obtain the same results as authors of the papers claimed. And only in very small percent of papers they were able to really get the same results. So the problem sits in the reproducibility. And how we are defining the reproducibility. The reproducibility for us is that you need to have the same code with the same data, and everything needs to be run in the same environment. So everything needs to be fixed. That's why we are using Git. That's why we are using a lot of the Docker. So the whole environment is in the Docker containers. And we are using a lot of Google storage to keep a copy of our data there. To ensure that all our models are reproducible, for every model, we are creating a very, very simple config file where you can find the commit, so you have the code. There is also the specification of the environment, the data which we have used, but also the parameters. And that dictionary of the parameters comes from the tf-up flags module from TensorFlow. So we are getting everything for free, and if you have this kind of JSON file for every model which you have created, it's very, very easy to have the reproducible research. It's very easy to start the same model to get it every time, and it will be always the same. So let's measure the impact of the project. We have been able to improve the customer experience because right now the urgent issues like payment issue or customer is not in their houses, we can respond them 4 times faster. And surprisingly, we also saved some money, even if it wasn't the goal. We saved some money because we find out that 7% of the emails shouldn't be read at all. I mean, they are spam messages, or they are like thank you at the end of the conversation, or they are just some kind of the autoresponder unsubscribes or whatever, this kind of things. The whole systems has been appreciated by European Contact Center Award, so we have been shortlisted there and we are waiting for final decision. So as you can see, very easily you can build the very simple solution which improves the real life. What next? Because for the emails we are returning the list of tags, later on we can very easily monitor the rate of the particular tags. So if we see that there is a huge spike in the warehouse issue, I mean the damaged item, we can very easily notify our warehouse team, guys, something is wrong with raspberries. So many customers in recent hours notify us that they got the damaged raspberries. What else? We can also track the sentiment because we have a tag with if customer is happy. We can track the sentiment over time. So we can check, okay, if our customers are happy during Christmas or not, because Christmas is crazy time for retail. And it's the busiest time through whole year, and we still don't know if our customers are happy or not during the Christmas. And thanks to this solution, we also can do that. And last but not least, we can also automatically detect what template should be used to answer the email. So if the email was tagged as a refund and customer wants to get the money back, we can very easily show our agent and advisor, this is the template, just put what product is about, and it will generate the ticket to other systems to give that refund back. So very flexible solution, very, very easy. And it's all about deploying machine learning into the real business. So rather than overcomplication, rather than trying to only build the technology for the sake of in the sake of the technology, you should build something very, very easy. So to summarize, why deploying machine learning in production, in machine learning, in business is hard? Because what you can see, I mean, what you are building, just machine learning is only a tip of the iceberg. Behind the scene, there is a huge business processes around. There is a lot of human involved into that process. There are SLA, there are KPIs, and there are also the law which you need to also need to adjust to these laws, like we did for anonymization of our data. So what you should do, turn off your computer, go meet some engineers, meet your business, understand where your machine learning needs to really work. And of course, don't forget about the software practice. Keep your model reproducible, because the deploying of the model is just only the beginning. And the only thing which I can wish you is successful deployment. Thank you.